Alright, so in this video we're going to do an introduction to functions. So we're going to talk about what a function is and some basic facts about functions that we're going to be seeing throughout the entire year. But before we even get into that, we just kind of want to generally talk about what this course is all about. What are we going to be doing pretty much every single unit for the entire year? So we're going to be asking questions like this. If you take a look at my example here, I'm saying let's look at y equals x squared. This is an equation, right? I'm allowed to input values for x and get back values which we assign to y. And we saw in the last video that instead of using y, sometimes we'll use a different notation which we called function notation. So instead we might get rid of this and we might call this f of x is equal to x squared. And so this is a perfectly just different way of writing about it called function notation. So the questions that we're going to be asking about this are, when I look at a function like this, when I look at an equation like this, x squared, what does the graph look like? You know, when I graph x squared, what does that look like? So, you know, you're not expected to know this entirely yet, but it looks something, this is again just a rough sketch, like a U shape, which we call a parabola, which again we'll get into more detail about. It'll look something like that, okay? And so we're going to be asking questions about this, and we're going to be saying, well, for the function, for the equation, what numbers am I allowed to input for x to generate this graph? Are there any numbers that I'm not allowed to input that would maybe give me an error if I try to type it into my calculator, or that just don't work? Okay? Are there also going to be any numbers that don't come out of the function when I plug in whatever I decide to plug in? Like, so maybe I say I plug in 1,000, what comes out? If I plug in -50, what comes out? If I start thinking about that list of all of the output values, are there any numbers that aren't ever going to come out of the function? And for x squared, that's actually, there's an answer to that. We can actually say we'll never get a negative number out. If I square 4, I'm going to get 16. If I square -4, I'm also going to get positive 16. So when I square numbers, I always end up with positive outputs. So answering this question, what numbers will come out for y? Well, the answer is only 0 and positive numbers. You will never get a negative number to come out of this function. So we're going to be having some conversations about what does the graph look like, how is the graph affected, what numbers can I input, what numbers can I output, right? So that's going to be every single time we introduce a new type of function, we're going to be asking those questions. Okay? We're also going to be looking at these types of questions. We're going to say, if I just take my regular function x squared and I just throw this +5 on the end of it, well, how does the graph change, right? We looked at this and said the graph kind of looked like this. What does this one look like? Does it move? Does it change shape? Is it still a U shape? Like, so we'll be answering questions about how changing a function also changes its graphs. Okay? We're also going to be asking questions like, because I put this +5 on there, are there now different numbers that I'm allowed to input or different numbers that I'm allowed to output? I could also do something like this, right, and now say, okay, well, this is still something squared. It's still the same type of equation. How does the graph change when I do this? Are there any numbers that I'm not allowed to input here, or are there any numbers that I will not get out of this? And so we're going to be asking those questions every single time we introduce a new function, which the first one that we're going to do is squareds, quadratics. We're going to be asking these types of questions. What does the graph look like? What are some properties of the graph? How does the graph move when I change the equation? What numbers can I input? Right. So this is the study of functions and the things that we're allowed to do to them, the things that we're allowed to input, the things that we're allowed to output from those functions. So that's just generally what the course is going to be about, and we'll get into a lot more detail about those things. We're going to be starting off by asking these first two questions and giving them kind of vocabulary names. The questions, what are we allowed to input, and what numbers could come out of the function after we input, right? And so when we do that, we're going to get lists that look like this. Okay, so this first definition is called a relation, and a relation is a list of ordered pairs. And ordered pairs are really just inputs and their outputs, right? So this list, 0, 2, is saying there was some equation or some function that I plugged in a 0 and I got back a 2. I plugged in a 5, I got back a 3, and then we went through this list and we made a list of ordered pairs. Whenever we make a list of ordered pairs, we call that a relation. Okay? If that particular relation has a very specific set of circumstances, we're going to call it a function. So if I take a look at this list, if it meets a specific criteria, then I'm going to call it a function. So here is the criteria. If in this list, every single input value has only one output value assigned to it, we're going to call it a function. So if I take a look at this one right here really quick, 0 is assigned to 2. So right now 0 has one output value assigned to it. But when I come way over here, 0 as an input is also assigned to 6. So I just found an input value, 0, that has been assigned to two different output values. That's a problem. I would say this is not a function, this list here that I made for relations, not a function because I found an input value that it was assigned to two different output values. If this last number was, for example, instead of being a 0, was like 10, now I would say it is a function because 0 is assigned to 2, so it has one output value. 5 is assigned to 3. I don't see any other 5 inputs. -2, I don't see any other -2. 10, I don't see any other 10s. Every input only has one output. Good, it's a function. So we're going to be studying a very specific set of ordered pairs, functions, where every input has only one output. Okay, so this is so this is really just saying if I were to go to this list and I were to say my equation is 2x plus 1, right? And we're wondering, is y equals 2x plus 1 a function? We're going to say, well, there's a relationship between 3 and 7, right? If I plug in a 3 here, okay, I get back a 7, right? So that's an ordered pair. Every time I input 3, I get back a 7, right? Because if I do 2 times 3 is 6, 6 plus 1 is 7. That's an input-output pair, okay? So the question is there any other value that I could possibly get out of this function when I plug in a 3? And it looks pretty obvious that when you input a number, you're only ever going to get one number to come back. Right? And so you might be asking yourself, well, where would you ever get two of them to come back? Okay? And so we're going to see this one a lot. Here's a simple example where when you plug in numbers, you might get two outputs back. If I were to go like this, y equals the square root of x, if I input the value 25, right, and I say x is going to be 25, this would look like y equals the square root of 25. And if I were to say, well, what's the square root of 25? Well, the answer is that there's actually two of them. There's a 5 and a -5. So my input value x, my 25, just gave me two answers, 5 and -5. So I would actually say that this radical right here, the way I have it now and the way it's defined, is not a function because the 25 for x just gave me a 5 and a -5 for y. So that's a problem. That's what we're trying to avoid, right? So we're going to see those kind of things. So we need names. I keep saying input value, output value, input value. So we need better names for those. So that's where we're going to kind of wrap this up. We're going to talk about domain and range. And so you might have seen these a little bit before. Domain is the list of every possible value that you're allowed to input into a function. So I'm going to use again this square root of x. This is always a nice one because it's got so many restrictions and things on it. So y equals the square root of x. If I were to say, are there any numbers, when we're thinking about the list of things that we're allowed to input, it's always usually helpful to think about, is there anything that I can't input? And then we can just kind of throw that stuff away and keep the rest of the list. So if I was looking at y is equal to the square root of x, there are a bunch of numbers that I am not allowed to plug in here. If I plugged in, for example, -9 or -12, this thing would give me an error. If you go to your calculator and you type in the square root of -12, it's going to say error, cannot do that. Okay, so the radical expression here, the domain, okay, which you'll see that we'll choose the letter D, is going to be only the x values that are greater than or equal to 0. This is my way of saying positive numbers and 0. Right? And so that's really what we're getting at, is this particular function has numbers that you are not allowed to input. Okay, so let's take a look at this one. Okay, so let's talk about range. Range is actually the same kind of idea, but now we're going to say, well, now that I know everything that I'm allowed to plug in, is there anything that will never come out of the function? So I'm going to make a list of all the things that will come out, but again, it's going to be helpful to think about, well, is there anything that won't come out, so that we can just throw that stuff away. So with my example here, I have y equals x squared, again, quadratics, which we're going to be talking a lot about for the first few weeks. Okay, if I were to say, are there any numbers that will never come out when you square? And the answer is yeah. We talked about this a second ago. We said when you square something, you always get a positive back. So I can plug in any number I want. You're allowed to square positive numbers, you're allowed to square negative numbers, you can square 0, you can square fractions, you can square decimals. So my domain for this one is I'm allowed to plug in anything. But when I square negative numbers, the answer is positive. When I square positive numbers, the answer is positive. When I square 0, this is the special case, I get a 0. So I would say in this case my range, okay, are only the y values that are greater than or equal to 0. So again, I'm just kind of saying the list of all the positive numbers, that's the only thing that's ever going to come out of this function. I can only plug in positive numbers, okay? So this is again the idea of domain and range. Domain is the list of everything that I can input, and we just want to think about, well, is there anything that's going to kind of get messed up when I plug it in that I'll never get back? And range is the opposite. Is there anything that will never come out of this function just because of the way it operates? Okay. So let's take a look at a list, and we're just going to kind of dip our toe into it a little bit. We're not going to get too crazy. We're going to say x plus 5. F of x is x plus 5. This is my first function. What are the domain and the range for this function? So I want to think about when I add 5 to a value, is there anything that's going to give me an error? Can I add 5 to negative numbers? Can I add 5 to positive numbers? Can I add 5 to 0? Can I add 5 to fractions and decimals? And I don't see any problem with adding 5 to anything. So I'm going to say in this case, the domain, which I'm just going to use a capital D, that the domain, and here's a kind of a new term for you. Okay, we're going to use an R with an extra line. This means all real numbers. Okay. So this is a math symbol that we use to represent pretty much everything. Every positive number, every negative number, every fractions and decimals, zeros, radicals. You're allowed to plug in anything you want, and you can add 5 to it, and that's fine. Okay? So now I'm going to talk about the range. This one's the trickier one to think about. Okay? So I want to think about kind of the number line and say, okay, if I add 5 to a negative number, what's going to happen? Well, it's still going to be a negative number. It's going to be a little bit bigger. So I can pretty much pick any negative number to plug in, and when I add 5 to it, I can get any other negative number. So I can definitely get back negatives. If I plugged in positive number, I'm going to add 5 to it, I'm probably still going to get a positive number. So again, I'm kind of thinking of, is there any weird stuff that's going to happen when I add 5? And the answer is no, not really. So I'm going to do the same thing here. I'm going to say that the range for adding 5 to a number is also everything. There are no restrictions on what I can plug in, and there are no restrictions on what's going to come out of this function, okay, for what we call linear functions like x plus 5. Okay, g of x we just talked about, x squared. I can plug in and I can square anything I want, so I'm going to say for this one that my domain is still all real numbers. I can plug in whatever I want and square it. I can square positives, negatives, fractions, decimals, whatever. Okay, but my range in this case is not everything, right? Remember we just talked about, we said you can only square, when you square things you will only get a positive number back. So I'm going to say in this case greater than or equal to 0. When I square 0, I do get 0. So it's 0 and up, and that's it. You will never get a negative number when you just simply square a value. Okay, so let's talk about this last one. This last one's the tricky one. So, square root of x. Is there anything that I'm not allowed to plug in to the square root of x? And the answer is yeah, there's a bunch of numbers that we're not allowed to plug in here. I'm never going to be able to plug in negative numbers. So I'm going to say my x's have to stay greater than or equal to 0. I can square root 0. Okay? So now we want to ask a different question. When I take the square root of something, what comes out? Right? Well, and when I take the square root, like, again, let's take our example of, like, maybe plug a 9 in here. If I plug in an x value of 9, this is going to be the square root of 9 minus 7. Well, the square root of 9 is 3 minus 7. Okay, and that's negative 4. So it looks like I can get some negatives to come out of this. Can I get all negatives to come out of this? Well, if I plugged in 0, we just said right here you're not allowed to plug in negative numbers into this function. So 0 seems to be as low as I can go. If I plug in and let's come over here and say the square root of 0 minus 7. Well, square root of 0 is 0. 0 minus 7 is negative 7. So it looks like I can get numbers from negative 7 and up, but how am I going to get anything smaller than that if I can't plug in anything smaller, right? I can't plug in anything smaller than 0. That's what the domain says. It says 0 and up. That's as far as you can go. So I can't do any better than that, which means I can't get anything to come out of this that's bigger than negative 7. So I'm going to say my range are only going to be the y values that are greater than or equal to negative 7. You can't get something smaller if you can't input something smaller to then subtract 7 from. right? So again, this is the tricky one. This is a little bit difficult, kind of expanding yourself to think about that. And so we're going to stop there with domain and range. We can talk about graphing and things like that, but you'll see that show up as we go through lessons.